Okay, we are
ไซครับ เอาใหม่ไหมกูขอโทษ
Okay
โอเคพร้อมกันนะ
Okay, we are
ไซครับ In today's world, there are serious threats, especially where sharp objects can pose a serious threat. Whether it will be in a school, in a workplace, or a factory. Detecting dangerous objects early can prevent accidents before they happen. With that in mind, we developed simple yet effective prototype using Arduino Uno, a buzzer, and LED lights to create a system that can detect sharp metal objects like scissors and cutters. This project combines AI and machine learning. When such items are identified, our system helps prevent accidents and increases safety awareness by alerting users when a dangerous item is detected. Now, you may be wondering, how is this project important? Why is it necessary? Couldn't people just recognize what's dangerous? Well, first of all, it helps reduce accidents for children in schools, since they are too young to know. It also helps remind employees in the workforce of the danger in their area. Another thing is that it can detect dangerous tools in areas where carrying such is not allowed. It can help security detect the potential danger and secure a safety regulation. And finally, our system helps prevent accidents and increase safety awareness by alerting users when a dangerous items can be detected. This project can be extended to improve the effectiveness of screening system further and incorporate beyond just two objects. Now, what can you tell about how the system works?
Okay, so how the system works? A camera captures the object in front of it. If it detects scissors, the green LED will be turned on and the buzzer beeps once. If it detects a cutter, the red LED will be turned on and the buzzer beeps twice. If no such object is detected, both LED and buzzer will be off along with the system waiting for a new capture to detect objects in standby mode. Moreover, we use teachable machine, a web-based tool that allow anyone to create and train machine learning models to make the system recognize scissors and cutters from image, including image from the internet and real objects. Moving on to the objective. Firstly, to verify that the system will detect the trained object and displaying what it is correctly. Secondly, to verify the behavior of LEDs and the buzzer are working correctly as stated or not. Lastly, to ensure the reset button and the whole system works smoothly. Alright, after we understand the idea of how the system works, then we are gonna test it. Let me remind you again that if the scissors are detected, the green LED will be turned on with one beep. If the cutter is detected, the red LED will be turned on. It will beep twice. If no such thing or any object is detected, both LEDs and buzzer will remain off along with the system waiting for a new capture. Pressing the reset button will remove the latest detect result and it goes into a standby mode, waiting for the next capture. During the experiment, we used many different images of scissors and cutters from the internet, including real scissors and cutters. It appeared to be that the system reacted quickly and gave quite good result. This indicates that the detection logic works as stated and the system can respond quickly and effectively pass.
Alright, let's jump into code overview. Alright. Our code is set up output as pin 8, 9, and 10. Pin 8 is for buzzer. Pin 9 is for green LED and pin 10 is for red LED. The call output is set to off, but our buzzer is active when it's low level, so we use high. And next, before we getting into the loop, we use serial available to receive string from the node rate. You know node rate, right? Right? So the string we use, string 1 for turn on green LED and turn off red LED, and beep the buzzer once. And string 0 is for turn on red LED and turn off green LED, and beep buzzer twice. And the last one is string 3 is for reset. It's like turn off everything, receive reset command, stand by to receive another input. Thank you. All right, that's all for us. Let's move on into the most important part of our project. Give to Peach. Feet.
In my part, I will present 4 nodelets. These are overall of 4 in nodelet, and I'm going to tell about the nodelet dashboard. It have the 4 parts. First, the capture button, webcam, reset button, and the last one is tech dashboard. It's called predictions. Next, what prepare image payload can do. Image payload using nodelet compare the machine learning server, and nodelet handle the communication between the camera and the machine learning servers. This part is very important in my project. Next one, X-text first card. The law of X-text first card pick up the number by the machine learning analysis with the nearest thing as scissor and cutter. Look at the right hand side pictures. It will show scissor about machine learning analysis with the numbers. And the next one, convert to the numbers. When you receive a string such as a scissor or cutter and reset it, convert the value to a number so you can simply send it to the Arduino via serial port. In the process part, you must have the 2 folders about ML servers and your projects. First, I will create the new terminal to open the machine learning servers. It's already turned on. And next, I open the news terminal again and command to open the nodelet projects. The terminal will give you the link. You can follow the link too. You must need to copy the link and type the UI behind the link. Now you can get in the dashboard. So I will switch the camera in the dashboard. The first one, I will scan the scissor first. The green light is turned on. Buzzer make the sound with the 1 time. It's be a scissor. And next one, I scan the cutter. The red light is turned on and buzzer make the sound with the 2 times. I will press the reset. the light is turned off. So I will searching the random image in internet. First one, I pick the cutter first, like this one. It got a cutter. And the last one, I will select this one, the haircut scissor. It got a scissor. I will press the recess. Now it's be done of the process part.
Next is our Node-RED dashboard, which includes a camera button in which it will connect the picture footage to your device, and then a capture button which will send the picture into the ML model so that it can figure out whether it is a cutter or a scissor. And the result will be displayed once the object was detected. The last one is a reset button which will reset everything and clear the result. And the next is a complete circuit of our project from the Tinkercad program. Now, that's all for our project. Thank you for listening, and remember, science never sleeps. Bye bye.